Hey there guys, this is just going to be a short video over 8.2 notes for sinusoidal models. We've talked about trig functions in regards to the unit circle, but today we're mostly going to be talking about them as wave functions with different characteristics like principal axis, periods, amplitudes, and phase shifts. Now there's a lot of notes on page 10 and I'm not going to go through all of it. Most of this video is going to go over example 4, but before we get there, let's talk about some important vocabulary. The first is principal axis. Principal axis is kind of what you can think of as the middle of your graph. So it's going to cut your graph in the middle. It is not always the x-axis. So if you have some type of shift on your graph, either above or below, so a vertical shift upwards or a vertical shift downwards, your principal axis will change accordingly. Now something else you have is a period. So these are periodic, which just means they are repeating functions. So in this one, or in this case, it looks like a sine graph. We know that a sine graph kind of makes this S shape. So we'll look here and we'll say, okay, that's my period. Now this S shape will repeat over and over and over again, but a period just tells me, okay, how long does it take for me to complete one cycle of kind of this S shape? Or if you have a cosine, the longhorn shape. There's something else, which we call amplitude. So for amplitude talks about distance. So amplitude is the distance from the principal axis to your maximum, or the principal axis to your minimum. You can also use that to kind of measure. And then phase shift means, okay, have I had a horizontal shift left or a horizontal shift right? Now, like I said, there's a lot of nice information here, so feel free to read through this on page 10 of your notes, but I'm mostly going to skip past all of this and go to example 4. So for example 4, we have our general equation, which is f of x, and I advise writing relatively small because there's actually a lot of things we have to do for example 4, and although you have about half a page or a little bit more than half a page on page 11, it's not going to be enough. So I am forewarning you, please write tiny. So we're just writing our formula, or the general form of this formula. There we go. Where each thing kind of has its own thing. So the a in this function, and it also works for cosine functions, so the general same idea. So we have a, which is my amplitude, b, which is going to be your period, and d, which is going to be in reference to your principal axis. Don't know why I did that. Now each one of these kind of have their own formulas to kind of figure out these values. So amplitude is going to be your maximum plus your minimum divided by 2. Your principal axis is going to be similar, and I'm just going to say PA for principal axis. It's going to be your maximum minus your minimum divided by 2, and then your period is equal to 2 pi over b. And in this case, and for the most case when we're talking about sinusoidal functions and we're on the coordinate plane, we're mostly going to be talking in radians, so that's why it's 2 pi over b, not 360 over b. So we need to write our example here, or our function here, from the given graph. So they give us some couple of values. So I'm going to graph it as such. So they tell you that we have something at 1, 2, which is a maximum. And they tell me I have another point, which is a minimum point, at 5, negative 8. So let's start by finding our amplitude. Or actually, let's go in order of this problem. This problem tells us for part A, state the equation of the principal axis. Well, your principal axis is the middle, so to say, of your wave function. So we're going to use our principal axis formula. So PA is equal to your maximum minus your minimum divided by 2. Now you'll need to know this formula, and it kind of makes sense if we're trying to get half the distance of something, and not necessarily the middle, just the distance between, or this one's principal axis. We do want the middle. In that case, for our principal axis, we are going to add. So let's change some of these formulas. Principal axis is adding, and amplitude is subtracting. So hopefully you didn't write in pen. But since we want the middle, you're kind of going to do the same thing that you would do if you were trying to find the average. So the middle of a data set, you would add all your values together and then just divide by your amount of values. So in this case, we're going to add our maximum plus our minimum and divide by 2 to figure out what's the middle of this kind of range of my wave function. The highest it goes and the lowest it goes. So when we're talking about maximum and minimum, we in particular mean for y values. Our y values will tell us our max height and our minimum height. So although we do have x and y coordinates, we're only going to be using the y values of our x and y coordinates. So we're going to look here and we're going to say, okay, well, the y coordinate of my maximum is 2. So 2 plus, and the y value of my minimum value is -8. So I'm going to have 2 plus -8. And 2 plus -8 is -6, which is just going to give me -3. This is going to be the d value that I'm going to plug into my formula. So we found our d value, and we actually did two things at once. So they told us, hey, the first part just says state the equation of the principal axis, and then part B says find the value of d. Okay, so we have already done that part. Part C says find the amplitude of the function. So now they want us to deal with the amplitude. So your amplitude is the distance between your maximum or minimum and the principal axis. And I'll actually write it out so that you can kind of have it in your notes. So since this one, like I was trying to say earlier, is in particular a distance, so we already know that we have a principal axis at -3, so I'm just gonna kind of eyeball it here. Ooh, that is too wide. So -3 would be about here. So we have a principal axis at y is equal to -3. So my amplitude is going to be the distance between my maximum and that principal axis. So I want to figure out what this distance is. Now you can kind of see what it is if we're going from -3 to 2, but we're going to use our formula. So here what we're going to do is we're going to say, okay, well, I know that amplitude is equal to my maximum minus my minimum. And remember, I changed this formula earlier. And once again, this deals with y values. When we're talking about max or min in general in mathematics, you're mostly talking about the y values of a graph. So your maximum was 2, or the y value of your maximum was 2, minus the y value of your minimum, which was -8. So this will give us, although we're using the same numbers, a different value because we're subtracting this time. I know 2 negatives make a positive, so this becomes 10/2, which is 5, which means my A value is 5, my amplitude. So I just found my amplitude. Sorry about the car or the airplane. Hopefully you can hear me okay. And once again, we hit 2 and 1, so we did part C. find the amplitude of the function, and hence find the value of a. So now we're on part E. They want us to find the period of our function. So period of a function is how long it takes to complete a cycle, or a standard shape like the S shape or the longhorn shape. Now in this case, since we know that you have a sine function, and we know we have a sine function because it tells us right here that it's sine, I'm going to say, okay, well, my sine function usually starts by touching the principal axis. Now you may say, well, my sine function starts at 0 typically, but here we can see that we had a horizontal shift because of that principal axis. We actually went down 3, and we're actually going to have a horizontal shift, a phase shift, which we'll get into as our last step. But before we get there, okay, so I can see here, it's going to start here and end here. And here is, and let's see if it'll show up. Now 1 cycle. Now, obviously periodic functions repeat on forever, but this highlighted in blue bit is my period, so it's going to tell me my length. So it looks like I go from here, which looks like it is -1 because it's between 0 and -2. So I'm going to say -1, and it looks like it keeps going to about 7 because it's between 6 and 8 right here, which means my distance, and I'll kind of rewrite these numbers. So hopefully you're using pencil so that as I adjust things, it doesn't change too much. That means my distance is 8. So the period of my function from beginning to end is about 8. So from here to here, it's going to give me 8. But I'm just going to get rid of that so it doesn't get too messy. So now that I have my period of my wave function, we can continue. Now, that's not quite my answer. So remember, there was a formula involved here, so period is equal to 2 pi over b. We want to find the b value that we're going to plug into our equation. Well, the period value we found, which was 8, it took 8 units to complete a cycle from beginning to end, and this is probably where most students are going to mess up the most. It just conceptually, it's hard for them to see where their function starts and ends, especially if it's not the parent function, so it doesn't start at 0. But hopefully you figured out where that a came from. If not, ask me during class. So 2 pi is equal to, or my bad, 8 is equal to 2 pi over b. I'm going to multiply both sides by b. So this becomes 8b equals 2 pi. Now, some of you know immediately how to get to your answer, so if you know how to do that, feel free to do that. I'm just showing you kind of the steps involved, so you're not like, wait, how'd she get that? So I'm going to divide both sides by 8 to get b by itself, and that was our goal, to get b by itself. So b is equal to, and I'm not actually going to get a decimal value. I like to keep things in terms of pi, so I'm just going to simplify the fraction to 8. So 2 eighths becomes 1/4. So I'll put this here, especially if you're listening on mute, so you kind of know where that value came from. And we now found our b value. So let's see if we did 2 things in one. Yep, part F wanted us to find it. So we did part E and F. Last part, find the smallest possible value for C. Well, to find my smallest possible value for C, phase shift is the one that's, besides period, the trickiest to solve for. So amplitude is pretty straightforward as long as you have your formula, and hopefully you think through it like me so you can realize, wait a minute, I was using the wrong formula. Same thing with principal axis. It's pretty straightforward as long as you know the formula. Now, they're not on your formula booklets, so you do have to have these period, amplitude, and principal axis formulas memorized, but once you have them memorized, they're pretty straightforward. Phase shift and period, calculations are involved. So we did our calculations for period. Now the calculation for phase shift, We know that our graph usually starts at 0, 0. Actually, no calculations. We're just going to look at our graph. So I'm going to zoom in a little. Now we know we're at -1. My graph usually starts at 0, 0. So since I start here now, that tells me that I actually shifted to the left. So rather than starting 0, 0, I'm actually starting a little bit before where I typically start. So when I plug in to my function, and if you remember absolute value functions or quadratic functions, exponential, anything from algebra 2. So I'm going to do part G and H together. Now, yes, there's a whole algebraic way you can do it, and I can show you if you want in class how to algebraically find C, but just by looking at it, we can see that we actually went left 1, which means my phase shift is 1. But you'll see what that looks like in a second. So all I'm gonna say is C is equal to -1, or my bad, +1. But once again, you'll see where that comes in. So I'm gonna start writing my equation. So my amplitude was 5. We know it's a sine graph. My B value was pi/4 x. Now this is where C usually goes. Now I went left 1. Now you may be asking, why does it say +1? Well, if you remember from algebra 2, inside lies, or inside is opposite. So if you're going left 1, you write +1, and if you're going right 1, you write -1. So hopefully you can remember that. And then our principal axis was 3, so we just put everything together. So now we have our equation with everything put together. And I'm going to write op for opposite. So hopefully you can remember, hey, inside lies. So now that I have my general equation, actually step H, so this really was just parts G. Part H says, hey, you have your equation, solve for these specific values. Now at this point, I run out of space, so I assume you may have run out of space, especially if you tend to write larger. I was writing small. But all I want you to do for this step, I would personally put it in a table of values. In your calculator. So it's just saying, hey, find the y value. So if x is 0, what's your y? If x is 1, what's your y? So on and so forth. Now, algebraically, you could say, well, if they want f of, and let's see, let's use orange, 0, then all we're going to do is we're going to take our function and then replace x with 0. So then you would say, okay, well, 5 sine is equal to pi/4 minus 3, because 0 plus 1 is 1, and 1 times pi/4 is just pi/4. Sine of pi/4 is square root 2/2, which you don't have to have memorized. You would just put this all in once in your calculator. So this is 5 square root 2/2 minus 3, and then you put that into your calculator. And you would go from there. So that's my cue to end the video. So put it into your calculator, see what you get. But you would do that over and over again for the rest of the values. Or like I said, table of values is your best bet. Instead of doing it individually for each number, especially on a time test, you don't want to spend time if you don't need to. The rest of them, yes, you had to algebraically find them. This last part, just use your table of values in your calculator. So if you have any questions, let me know. But this is generally your notes, and then you'll start your practice.